Hello, deep learners. I'm Andrew Ng, founder of DeepLearning.AI, and I'm excited to welcome you to our global deep learning community. I know that many of you are here today because you want to break into AI and build your career. I hope that being part of this community will help you to do so. To give you a proper welcome, I'd like to show you around the DeepLearning.AI offices and meet some of the teams so that you can see where it all happens.
Oh, hi, Andrew.
Do you want to tell our friends at Pine AI what you do at DeepLearning.AI?
Sure. Hi, everyone. I make articles and other media that help people learn about AI and help them understand the huge impact that AI is having in the world. Today, I'm putting together the next issue of The Batch, our weekly newsletter, and I'm looking for the biggest stories of the week to keep our readers informed.
What's been the most surprising thing you've run into working on The Batch?
How much is going on in this field? There's never a dull moment. You might think from the outside that machine learning engineers really understand everything about AI, but nobody understands everything about AI because this field is just coming to life right before my eyes as I put this thing together every week.
All right, I know you're really busy, so I'll let you get back to it.
Thanks. See you later.
Let's go meet Kian, who helped me create the deep learning specialization. He's working on an exciting new project. Hey Kian, so do you want to tell the people at Pine AI what you're working on?
Yes, sure. I'm leading a project called Workera, focusing on helping people get offers in AI and navigating their career by testing their skills, preparing for interviews and certifying them, as well as matching and referring them to good jobs in AI.
That's really cool. And what's the most exciting part of your day?
You know, the AI field is new, organizations and jobs are still misunderstood, so I'm excited to help people understand what different types of jobs exist in the field, what tasks they will work on, and what skills are needed to achieve those tasks.
That's really important work. Well, it's nice chatting, and now let's go chat with Hotel, who is on their product team. Do you want to say hi to our friends at Pine AI and let them know what you're working on?
I would love to. Hi, everyone. I lead the product team in DeepLearning.AI, where we create AI education content accessible to people all around the world. People like you.
And what are you most excited about right now?
I am so excited to see our community grow and to see how eager people are to learn more about AI.
Thanks, also.
Thanks, Andrew.
So, as you can see, our team is working hard to support you and help you learn. It's never been easier than before to break into AI. So if you want to build a career, you can leverage online resources available, including open source code, datasets, papers, and online courses like a deep learning specialization on Coursera. As part of this journey, I hope you get your hands dirty too. Don't be afraid of diving in to build your own project, or go ahead and try to replicate a research paper that you're excited about. One thing that I've seen help a lot of people succeed is if you can build a community or find a community of fellow deep learners you can meet with and study with on a regular basis. In fact, I hope that this Pine AI meetup that you're at right now will be a good place for you to meet these people. I hope you enjoyed the event today and that you learn a lot, both from the talks and from each other. And once again, welcome to the DeepLearning.AI community.
Okay, so we will be starting shortly. Till then, maintain patience. Just give us 5 more minutes. Okay, so welcome everyone. Thank you for joining us here. Here's a hearty welcome, big and warm enough to encompass you all. So to say that I'm so thrilled to see you guys here is an understatement. I'm Sukanya Sahu and I'll be the host for today's session. So we also have with us Akhil Soni, who is a speaker for today's session. He completed his bachelor's and master's from IIT Delhi and worked as a software developer at IBM. He is now currently working as analytics engineer at Schlumberger. So without any further ado, let's see what we are expecting to learn in this event. But before that, we have a special greeting video by none other than Andrew Ng, who is the founder and CEO of Landing AI, and also the founder of DeepLearning.AI, co-founder and chairman of Coursera, and also an adjunct professor of computer science at Stanford University.
Hello, deep learners. I'm Andrew Ng, founder of DeepLearning.AI, and I'm excited to welcome you to our global deep learning community. I know that many of you are here today because you want to break into AI and build your career. I hope that being part of this community will help you to do so. To give you a proper welcome, I'd like to show you around the DeepLearning.AI offices and meet some of the teams so that you can see where it all happens.
Oh, hi, Andrew.
Do you want to tell our friends at Pine AI what you do at DeepLearning.AI?
Sure. Hi, everyone. I make articles and other media that help people learn about AI and help them understand the huge impact that AI is having in the world. Today, I'm putting together the next issue of The Batch, our weekly newsletter, and I'm looking for the biggest stories of the week to keep our readers informed.
What's been the most surprising thing you've run into working on The Batch?
How much is going on in this field? There's never a dull moment. You might think from the outside that machine learning engineers really understand everything about AI, but nobody understands everything about AI because this field is just coming to life right before my eyes as I put this thing together every week.
All right, I know you're really busy, so I'll let you get back to it.
Thanks. See you later.
Let's go meet Qian, who helped me create the deep learning specialization. He's working on an exciting new project. Hey Qian, so do you want to tell the people at Pine AI what you're working on?
Yes, sure. I'm leading a project called Workera, focusing on helping people get offers in AI and navigating their career by testing their skills, preparing for interviews and certifying them, as well as matching and referring them to good jobs in AI.
That's really cool. And what's the most exciting part of your day?
The AI field is new, organizations and jobs are still misunderstood, so I'm excited to help people understand what different types of jobs exist in the field, what tasks they will work on, and what skills are needed to achieve those tasks.
Yep, that's really important work. Well, it's nice chatting, and now let's go chat to Hotel, who is on their product team. Do you want to say hi to our friends at Pine AI and let them know what you're working on?
I would love to. Hi, everyone. I lead the product team in DeepLearning.AI, where we create AI education content accessible to people all around the world. People like you.
And what are you most excited about right now?
I am so excited to see our community grow and to see how eager people are to learn more about AI.
Thanks, also.
Thanks, Andrew.
So, as you can see, our team is working hard to support you and help you learn. It's never been easier than before to break into AI. So if you want to build a career, you can leverage online resources available, including open source code, datasets, papers, and online courses like a deep learning specialization on Coursera. As part of this journey, I hope you get your hands dirty too. Don't be afraid of diving in to build your own project. Or go ahead and try to replicate a research paper that you're excited about. One thing that I've seen help a lot of people succeed is if you can build a community or find a community of fellow deep learners you can meet with and study with on a regular basis. In fact, I hope that this Pine AI meetup that you're at right now will be a good place for you to meet these people. I hope you enjoyed the event today and that you learn a lot both from the talks and from each other. And once again, welcome to the DeepLearning.AI community.
Okay, so that was the special greeting video by Andrew and G. And now, without any further ado, let's see what we're going to learn in this event. So I'm going to share my screen now. So, deep learning. Now, deep learning in itself is a part of machine learning, which again falls under a huge umbrella of artificial intelligence. Deep learning uses artificial neural networks that help in designing what we need, and the input is fed to the layers in order to process it. So, a simple neural network, something looks like this. So this is the basic architecture of a neural network. We have an input layer, which where we feed our input data sets, and an output layer where we get our desired output. We also have many hidden layers in between, not approximately two. Here is just an example. We have many hidden layers in order to process a huge data set. Hidden layers are the layers of perceptrons, similar in the brain, and here it actually processes the data that is fed to the system. Now let's see some of the common types of neural networks. We have first recurrent neural network, which is not like the traditional neural network, because in traditional neural networks, every input and output layers are independent of each other, but not in this case. Here, the previous output is required to process the current step, and hence the name recurrent neural network. It has various applications. It is used in speech recognition, machine translation, time series prediction, robot control, music composition, speech synthesis, and many more. We also have support vector machine. It's not generally called a neural network, but it's a mixture of neural network and an algorithm, that is support vector machine algorithm. It is basically what it does, it classifies whether a given input falls under category 1 or category 2, that is yes or no or 0 or 1. It has it also has many applications where it is used in face detection, text categorization, classification, handwriting recognition, and bioinformatics. Next, we have convolution neural network, and that event we're gonna talk about today is mainly revolving around convolution neural network, because it uses image as an input and processes it to classify which category it falls. So here we see that we have an image as an input, and it is processed through various layers of neural network layers, and it actually uses RGB pixels. Like an image will be divided into its pixels, namely red, blue, and green, and each pixel will be then processed in order to get our desired output, which is then classified according to the image. So that was a brief explanation about what convolution neural network actually does. Now let's see some history of the object detection. So the first is Paul Viola and Michael Jones, which was like the starting of the object detection era. So what they did was they hand coded each location of eye, mouth, nose, faces, every feature of it, and they fed the data to a neural network, which was then processed to get the desired output, which was like categorize them. It fits a human face, a cat face, a dog face, and so on. So it actually was very useful because it was the first time that it detected a real time webcam data and classified it and detected what the image was. So after that, it was seen that it has very stunning demonstration of computer vision, and it was very mm, high work at that time. Soon it was implemented in OpenCV, and face detection became synonymous with called Viola and Jones algorithm in 2001. So here's a difference between image classification and object detection. Image classification, basically what it does is it classifies if an image is of a particular type, whereas in object detection, it detects what the object is in an image and categorizes it as, here we can see that it has an image that has both cat and a dog, and it classifies the area with cat as cat and the dog with dog, whereas in image classification it only recognizes what this image is. Then came the histograms of oriented gradients in 2005. So it was invented by Navid Dalal and Big Tricks. So what they did was, for every single pixel, they had to look for the surrounding pixels. And here we see that for every pixel, there is an arrow marked towards the darker pixel surrounding that pixel. And after doing this to every pixel available on that image, we got an image which looks something like this. Here it is very appropriate to say that it's a figure of an image, a figure of a human holding something. So this is what histogram of oriented gradients did. It matched every pixel to its surrounding one and marked an arrow directing towards the darker one. Then came the deep learning era in 2012, which mostly use convolution neural networks that I discussed earlier, and it was very commonly used for image classification. They fed the image and they process it to classify whether this image is that or something else. So after that, we have YOLO. As the name suggests, you only look once. So mm, it is the latest technology right now, which came around 2 to 3 years ago. But as we know, face detection and object detection was there much earlier from the 19th. But here we see that what is so special about this. The special thing is the technology was able to recognize the images of a real-time webcam feed, and due to its algorithm, it took a few seconds to recognize what the object was. So that's it from my side. More explanation will be given by Akhil on YOLO technology and many more. So Akhil, you can take over now.
Thank you, Sukanya, for the detailed introduction and for the hosting this event. So I hope you all can see my screen, right? Can you see my screen? If someone can just vouch in
Yeah,
the
yeah, we
chat.
can see.
Sorry. Yeah. Okay. So great. So so that was it. Then, thanks a lot everyone for joining and
I
having
guess
me over here.
There's something
Yeah.
wrong with the screen. It's going off and on again.
Okay. Let me share it again. It's still going off and on, right? Yeah.
Yeah.
Just give me 1 minute. Maybe I'll try reconnecting, or let me just. Yeah, it's better now, right?
It's fine now. Yeah.
Yep. Yep. Sorry. Okay. So yes, real-time object detection, because of course. Sorry, I have a sore throat. I'm not sure why, but okay. So because YOLO. Uh, so hello, I am your speaker for today, Akhil Somi. As Sukanya introduced me, I am an analytics engineer at Schlumberger as of now, and I was a former software development engineer at IBM. Okay, so before let's just dwell into the talk straight away now. Okay, so this is a famous quote said by Alan Turing in 1947. So what we want is a machine that can learn from experience. So as you all know, Alan Turing is the father of modern computing, and this is indeed what we know as machine learning in today's world, because this is exactly what machine does. When we say machine learning, as the name suggests, what we want is it actually to mimic a human. That whatever a human can do, the machine can do. That's the basic aim for us. Okay, so it's ironic that Alan Turing put it in this way, way ago the machine learning term was introduced in like in 1947. So yeah, so that's then. Now what is deep learning? So there is a lot of buzz going around this word that about deep learning, ML, and artificial intelligence. So, as in the previous introduction talk, you might have seen that deep learning is a subset of machine learning, and machine learning is indeed a subset of very huge domain called as artificial intelligence. But what exactly is deep learning? Okay, so to put in layman terms, deep learning aims to create machines which use techniques inspired by the human brain's ability to learn. Until recently, we didn't have enough data or computing power to make machines learn. But these days, we have a lot of data. We have huge amounts of computing power with GPUs and everything. And these days, deep learning is really the next big deal. And currently, as we mentioned in the earlier scenario, that deep learning neural nets have many layers of abstraction. They range from simple concepts to complex ones, and that's why you notice the deep in deep learning. On the other hand, it has various applications, like infinite number of applications ranging from medical diagnosis, surveillance, robotics, and even in the automotive sector, we have self-driving cars, safety, and other computer vision applications, even speech to text. Okay, so which brings me to an application of speech to text. So how does the speech application works? Okay, so there is a difference when we say voice recognition and voice detection. Okay, so Alexa is a typical example of speech recognition, or basically OK Google, Siri. All these applications are nothing but speech applications. Okay, so what they do is like how is Alexa made, or basically what is the algorithm, or what is the thought process behind Alexa? So that it's very broadly speaking, it can be classified into three types. The first step is to record voices. Step two is like to input voice data, and step three is train the speech algorithm. And when we say train, it basically consists of a number of algorithms like neural nets, convoluted neural nets, and tons of data plus processing of the data. So then after that, we come up with a model, and then we predict. So the prediction part is equivalent to of you can imagine it as when you say Alexa play the song. So the model of Alexa interpreting your words, which are play the song, whatever. So interpreting those words and converting them into action. The action basically will be playing the song. So that part of the model is known as the prediction part. So that's how a model is made. Someone is saying disturbance in audio. Okay. Um, is it better now, or it's is there still disturbance? No, no, it's not better. Um, is everyone facing the same issue?
I guess it's a mic issue.
Okay. Okay. So just give me. Yeah. Sorry. So is this better now? Okay. Okay. Thanks a lot. Yeah. I guess there was some issue with my mic, but okay. So, so where were we? Yeah. Okay. Raghu still says no. Uh, so is it not better? No. Yeah. Hello. So is this better now?
Yeah, it's better.
Okay. So better for everyone. Yes. Okay. Sorry. I guess there were some issues. I don't know what happened, but yeah. Anyway. Sorry. My bad. Then yeah, I was saying about the speech recognition, right? So so yeah, when I say Alexa, we have discussed that. Okay. So now let's move ahead to the next thing, which is of image classification versus object detection. So again, this is something already discussed. So I'll just go through this really quickly. So when you say classification, it just means that you have to classify the image and label it. So it can be a cat. And when you say classification plus localization, that means you also have to predict the position of the object in that image. So in this case, if it's a cat, where exactly is this cat? Basically, you have to draw a bounding box around the object. So this is known as classification plus localization. And then finally, we have object detection. So in object detection, we have multiple objects to be detected in the same image. Okay, so for example, you can see here cat, dog, duck, and we have to draw a bounding box around all the objects that are detected. So as you can see, there is an overlap, as in there is an overlap between the bounding box of cat and dog. There is an overlap between the bounding box of duck and dog, so which is fine, because because the only aim of the object detection algorithm is to detect the objects in it and make a bounding box around those objects. Okay, uh, so then we have, so this is the example of the YOLO algorithm predicting the objects in an image. So I'll be going through this implementation now in just 5 minutes. So what I have done is I have used the YOLO algorithm, which means you only look once, and I have given this image as an input, and you can see there are multiple objects being identified by the algorithm, which is like person, and also you can see a probability score assigned to that. So that means that is basically a confidence score which the algorithm predicts. So according to YOLO, the pink bounding box in the person is 97.53% or 99.77%. So YOLO is that confident on the bounding box being a person. Basically, it means that. So, and there are multiple objects like chairs, TV monitors, person, so on. Okay, so so then yeah, so before going into the implementation part of YOLO, I would like to spend a few minutes on neural networks and convolution neural networks. So basically neural networks is just an algorithm which mimics the human brain, and it tries to get some sense from the data. So for example, in this case, okay, let's consider this example of the image. When I input this image, what is it according to the machine? According to the machine, it is just some numbers, okay, some random numbers, and those would be the pixel values. Okay, so converting those garbage values into these objects, like how to do that. So basically that's wherein the neural networks part comes, where we have multiple hidden layers. Basically, these hidden layers perform the operation of converting your input image into your output, and output basically being the classification, which is your cat or dog or whatever. Okay. Then, how different is a convoluted neural network from neural network? So, convoluted neural networks are the basic building blocks for most of the computer vision tasks which are there in today's world in the deep learning era. YOLO was actually originally written in darknet. Okay, so darknet is a framework written in C and CUDA, and so YOLO algorithm was built in that. But because, as you all know, C language is not that user friendly, so there is also a Python implementation for YOLO. And coming back to this convoluted neural networks, so what do we want? We want some algorithm that looks at an image, sees the pattern in the image, and tells what type of object is there in the image. For example, if the image is of a cat, we want the algorithm to output CAT. Okay, and if the image is for a computer, it should output laptop or something like that. So as I told you, so the image is basically a 28 cross 28 pixels. So assume the image is of size 28 cross 28, and what will the computer do? The computer will make some patterns like vertical edges, horizontal edges, round shapes, and so on, and then make sense of the image. Okay, so how does a convoluted neural network differ from a normal neural network? So if you would notice, in a normal neural network, all the layers are fully connected layers. So when I say fully connected layers, I mean that each neuron in the input layer is connected to every other neuron in the output layer. So if you can see, this neuron is connected to this, and this, and so on. Like all the neurons are connected to all the neurons. But in convoluted neural networks, this is not exactly the case. I mean, not necessarily. So here we have something known as feature map. So if feature maps, if I have to say, then you can consider it as one particular feature of the image. So for example, if the image is of a zebra, Okay, then features might be something like stripes, or maybe the mouth of the zebra, it looks in some particular way, or so and so on. Okay, so initially the features, like if you see here, if you see this first layer, initially the features might be very basic, like maybe just a black patch, and then as you proceed to the further layers, it gets more and more complex, and then in the end, it can be as specific as a black stripe or a combination of black and white stripes. So that can be a feature. Okay, and so on. So finally, the ultimate aim is to predict. If you have, suppose, 10 classes of images, like you have a car, truck, van, bicycle, aeroplane, so you have 10 classes of images, and then ultimately you have to assign one class to all the image. Okay, so if you have an image of truck, then your algorithm should output truck. So basically, this is how convoluted neural networks kind of differ from actual neural networks. Okay, so so I know I have not this is not about the this session is not about the convoluted neural networks. That's why I'm not going in depth here. But if you have any queries, you can ping me, or post session you can ask them to me. So I just wanted to give a primer on convoluted neural networks and what is it before going to YOLO, because the YOLO is based on CNN, convoluted neural network. Okay, so so yes, now how was the evolution of object detection algorithms? So basically, the first algorithms were sliding window based algorithms. So let me explain you what is exactly a sliding window based algorithm. So for example, if you have a huge image, suppose the size of the image is for example 726 cross 726 pixels. Okay, then a sliding window, it means, suppose we make a window of 12 cross 12. Okay, we apply our entire algorithm on that 12 cross 12 block and predict what is it. So suppose if the first 12 cross 12 block gives me nothing, I mean it gives me say stripes with a probability of just 10%. So then we say okay, and we just slide that window throughout. So you can imagine, right? If there is a 12 cross 12 block, we will have to slide it horizontally and then vertically to cover the entire image. So these were the first types of algorithms which came into existence when we say object detection. Okay, so you can see there is a huge problem in this. First, it is computationally very expensive, because you end up computing for the same part of the image multiple times. So for example, when you slide the window, majority of the part of the window is common, so which is really an overhead. Okay, so that is not really required, and then it becomes very hectic, and it becomes very computationally intense if the image is huge, as in if the image is of very good quality. If it's of like 726 plus 726 is a very average quality image, but if you consider an HD image or a full HD image, then these algorithms won't really work. Okay, so then the next set of algorithms which came along the line were again sliding window algorithms, but optimized by selective search, like RCNN and fast RCNN. So basically, these are pretty new algorithms wherein we optimize the sliding window based algorithms by using selective search. When I say selective search, it means that we won't blindly slide the window. Okay, while sliding the window, we would first check that whether it's a good approach to slide it or not, and we would first identify the region. Like RCNN stands for region convoluted neural network, regional convoluted neural network. Sorry. So we will first identify the region wherein we predict, okay, this is most likely going to give me my object in the image, and then we just slide our window in that particular region instead of sliding the window in the entire image. Because for example, if the image is of a car, then 60% of the image won't contain a car. Like suppose if the car is in the center of the image, all the edges would be blank as in it would just be some garbage which we are not interested in. Okay, so these are called region proposed algorithms. um, then the next set of algorithms which came was, again I told you, algorithms which are region proposal network, like faster RCNN, and then finally came YOLO and SSD, single shot detectors. So let's see what YOLO is about. So you only look once. And what is YOLO? So So basically, this is the architecture of YOLO, wherein we have an input image, and there are two primary components: the feature extractor and the detector. The feature extractor just extracts the features, feature embeddings, and these features are fed into the detectors to get bounding boxes and class information. So, and you can see it's there are multi-scale features. So what does multi-scale feature mean? Multi-scale features again is analogous to the feature maps of convoluted neural networks. So again, we'll just prioritize on some features like, as I told you earlier, right? Like these zebra stripes, or the or if you consider the image of aeroplane, then you can consider one of the features as the wing, because that is something which can distinguish an aeroplane from other vehicles. A bus won't have a wing, but an aeroplane would. So these you would have to come up with these features, and YOLO does exactly that. The first block, which is the feature extractor, which is the most important one, which predicts how many features are there and what type of features would be there. Then the detection part will just detect that whether it's basically it's the classification part, that whether it's a cat or a dog or whatever. Okay, and drawing the bounding box, as in once you have detected the image object, you also have to draw the bounding box and specify the position of it. You just can't stop by saying ki, it has an aeroplane, but you should exactly pinpoint the position of the aeroplane too. Okay, so now let's go on to the implementation part. Okay, so there are two types of implementation. Okay, when we say YOLO, so YOLO is an algorithm. Okay, the developers of the YOLO, as I told you, they made this in darknet, which is based on C and CUDA, and then many people have their own implementation for Python, because Python is much easier to use. So when we say we have to implement a YOLO algorithm, there are multiple ways. One of them can be either you yourself do the training of that algorithm, as in you collect images for training. You suppose, you, for example, you have 10,000 images or 15,000 images of various classes, depending upon your use case. Suppose if you want, your use case is like your use case is to predict face recognition, or face detection is your use case, then you should have 10,000 images of different scenarios where the faces are there, where the faces are overlapping, and like images which doesn't even have a face. So you would have to generate your own training data, or else there are many open source training data available which you can use directly. Okay, then you can train your model, your YOLO model, on that data, and come up with the trained model, or come up with the user like model pertaining to yourself, like it's customized according to what your use case is. Or else you can simply download some pre-trained models, because YOLO is a very nice library, nice algorithm, and many users have themselves made customized training models for their purposes, and they have open sourced it so that everyone can use it for free. So suppose if you search on Google for a face detection and face recognition YOLO model, you'd probably find it, because someone would have already done it and uploaded it on the internet. Okay, so yeah, so here in this case, in today's demo, I will be using a pre-trained model. I will be using a pre-trained model from the COCO dataset, and I'll just check 1 second. So if you have any queries, just please ping in the chat, or feel free to pause me or interrupt. I'll answer them, or else if you want, you can ask your queries at the end also. So yeah. Yep. So now the first step is to basically import all the requirements. What we need is Python 3.6. We need TensorFlow. Yeah, correct. I'm just coming to your question, Raghu. It's based on TensorFlow Keras. Yeah, you are correct. So as you can see, we need TensorFlow and we need OpenCV. OpenCV is not as such required, but if we want to build bounding blocks, we require OpenCV just to make those rectangles. Otherwise, it's fine. So OpenCV is required for that. And then it would really help if you have a GPU for faster performance. If you have a GPU, then TensorFlow has a different library for GPUs, customized for GPUs. We can download that and we can use that TensorFlow. then or else so it doesn't matter. I mean, you can use both TensorFlow 2. The version doesn't matter. It's fine. Like it has backward compatibility. So if you can use 2.x or also the other version. So so yeah, we have to first import all the things like TensorFlow, and yeah, I was talking about GPU. So GPU really helps because these algorithms, YOLO and every such algorithms, are very computationally intensive. So having a GPU really helps. It speeds up the training process. If you are building a training model on your own, then GPU would help. If I want to give you an estimate, then if you don't use GPU and like on your normal laptop, it might take around 3 to 4 days for your model to train, just for your model to train, depending on how many training data, how much is the size of the training data, and how many epochs do you use. So yeah, if you have a GPU, it might be reduced to several hours. But currently I don't have a GPU, sadly. I have my own laptop, and that's the one of the reasons why I'm using a pre-trained model, so that I don't have to spend so much time training my own model. And but yes, it's fine. I mean, get a GPU on Google Cloud or AWS, and they are free. As in, like, I'm not sure, but they won't cost more. I mean, it would be very cheap. Like even a GPU for some 1 month or something like that. You can explore. I mean, you can explore on AWS and GCP, Google Cloud. So yeah. Then we import all these libraries. Then I have defined some options, like to choose weights and to choose classes. So as I told you, I have used a pre-trained model on the COCO dataset. So COCO dataset has 80 classes, 80 classes like person, mobile. It has those many labels, 80 labels. And then so what do I do is I just download the weights from Google. You can just search YOLO v3.tf. This is the sorry, YOLO v3 is the weight. You have to download it, and then the first task is to convert your YOLO weights to a TensorFlow model, and let's do that. So sorry, I guess yeah. So when I say Python load weights.py, I have made my own functions to load these weights. And when I say load weights, it's nothing but just converting this YOLO v3.weights to a TensorFlow model, which we can use in detecting our images. Okay. So yeah. So now I'll just show you a live demo of how this algorithm works. But before that, as I told you, suppose if I give this image, this is a very popular meme these days. I mean, it has been popular since long. Then what do you think YOLO will give us? So YOLO gives us this. It very accurately detects so many 8.46%, cup with 99.81%. It even detects this apple, and you can see it didn't detect this spectacle. So it's good. Such amount of details is very nice. I mean, given the, and it's really real time. So I'll just one
screen. Okay. So this is one video which I found online. So this is, I'll play the video. Yeah, so this is just a 10-second video, and okay, I'll just use this video as an example, and then I'll use my camera as well. Okay. So I'll say Python detect video I provide my input as sorry, minus minus video. I provide the path as data video paris.mp4. Then I provide the output as I can say detections and maybe paris out.avi. Okay, so let's see. So the FPS would be very less, as in the reason being again the same, that I don't have a GPU, so you might see a very lagged version. But okay, so oh sorry, there is a typo. Output. Yep. So as you can see, it is processing in real time, and the frames per second is very less because again of the GPU issue. I don't have a GPU, and if you see, it's processing real time. As in, as the video is going on, it's building bounding blocks across every object which it can detect. So you can see chair, cups, person, and mostly it's these three types. Bowl, you can see a bowl here and a dining table here. So this is one of the parts. Then I'll stop this, and if you want to see the complete video, I have it here. Detections, this is the one. So here the FPS would be a lot. So okay, so this is a different video. This is not the Paris one. This is the one. Yeah, so here as you can see, the FPS is very fast because the video is already saved, as in it's not rendering it dynamically. That's why the FPS was this fast. And now let's see what happens if I say I change this name to out live demo, and instead of using a pre-saved video, I just use my webcam. Okay, so let's see. Yeah, so I will, let me bring it here. Yeah, so as you can see, it detects me as a person. I'm glad it detects me as a person. And suppose if I bring one more object here, so let's see if it, yeah, you can see it detects it as a cell phone. Okay, and this video is being saved to the file which I made, and if you can see, it will detect this bottle also. So yeah, it detects it as a bottle, but maybe I have to, so if I do it like this, then it will detect both of them. It should wait, I don't know why it's, yeah, so it detected the bottle, right? I'll just wait for some while. Yeah, so yeah, basically it can detect any of the 80 lists, 80 items in the class. And I'll just stop this. Yep. So the, you can also see it here. out live demo. Yeah. So the frames per second is a lot, as I told you, because it's not dynamically rendering, it's a saved video. And yep, so there are a lot of pre-trained models of YOLO available. One second. Yeah, so there are a lot of pre-trained models. As you can see, what I have done was I have it here. Okay, so I have this YOLO v3.weights. This file is freely available, open source. You can download it. Okay, then there is YOLO v3 tiny. Tiny is a very light algorithm, as in the training is it's not that accurate, but it is really fast. So if you want, I can show you the difference. So what I have done now is wait. Yeah, so this when I ran this, it was using the YOLO v3, not YOLO v3 tiny. Okay, so let me just set the tiny flag. One second, let me just have a look. Just give me 1 second. Yeah. Yeah, so I provide the firstly I need to provide the video. It will be the same data video. Let me say Paris for this time. No, I did Paris already. Okay, let's do Paris. So Paris, and then while providing the weights, I say minus weights. Here I say weights slash YOLO v3 tiny. Why is it not completing? Weights. Yeah. YOLO v3 tiny.tf, and then finally the minus tiny flag. Okay, so you would notice a difference now. The frames per second would be really high. It would seem very real time because this is much faster. Okay, wait. So yeah, so as you can see the difference, right? In the earlier case, when we used YOLO v3, which was not tiny, the frames per second were much slower, and it detected a lot more objects than this YOLO v3 tiny is detecting now. But this is really fast, and you can see it's almost real time, as in it's very good. So let me just do the live version also here. Let me close it, and I have to just change here, and I have to say 0. So yes, it still detects me as a person, and so let me check if it detects this as a phone or it doesn't. Okay. Maybe if I get it closer. No. So yeah, it's less accurate because the training is, I mean, the accuracy is very less in YOLO v3 tiny. and that's the reason it is actually really fast. You can see the difference here also. I mean, when I'm live streaming it, when I remove the tiny flag, wait, let me just do that so that you can get a hang of what I'm saying. If I just remove this and I remove YOLO V3, so you can all just play with these weights, and you can also train your own weights, but don't take a huge data set, or else it will really take around 20 hours, 24 hours. So yeah, as you can see, the FPS is drastically reduced. It's 1.25 now, and in the earlier case, I guess it was 6 or 10. I don't remember, but yeah, it was much more than this. Okay, so it's a very simple implementation. There are libraries everywhere. Uh, you can have a look. You can have a look on the libraries, and you can just play with it. So yeah, I'll just. So basically, all these are weights. I have a customized weight, but I don't have it here now. Okay. Anyway, I don't have it now. So for me personally, I'm using YOLO in an application which is helping the blind people. So I'll tell you what it is. We have we are working on something known as Mavi, mobility assistant for visually impaired people. So what it would do is it would actually just there would be a camera, or there would be a webcam, or maybe some sort of camera attached to the shoulder of a blind person, and it would be live streaming the video in front of it, in whatever comes in front of camera. It will be live streaming that video, and there will be, and we will use YOLO. I'm like, our aim is that we would use YOLO. We would train a YOLO model to detect 6 different types of things. One is the face. The next is a signboard. The signboard detection, so that they can understand the signboards. Then we would have a pavement detection, so that they know that they are on a footpath, or they are on a road. Then we would have animal detection, like cow, dogs. Currently we are, so these are the classes which we are thinking of for training the YOLO model. Okay, and then finally we would have the OCR for reading out the text, and then in the end there would be a text to speech, so that the blind person can actually hear it. So our end aim is that there would be a webcam attached to the shoulder. It would live stream the video, and then it would give output on a real-time basis of what is there in front of it. So for example, if a person is there, then the app would say like a face detected in the north or 5 meters ahead. Or if there is a signboard, then it would say signboard detected, and it would read out the signboard, like go left for something, go right, or go straight, or whatever. And if there is a cow or dog in front of it, then it would say animal detected on your right, on your left, depending on the positioning. So you see, right, it is the perfect application for object detection. Like, we want the object to be detected, and we also want the location of the object in real time. And YOLO is really fast. If it's run on a GPU, then and the accuracy is also good as compared to other algorithms like faster RCNN and SSD. So yeah, we are still exploring it, but yeah, I just thought to share this with you all, that this and plus very recently YOLO V4 has been launched. Sorry. So this was YOLO V3, and very recently YOLO version 4 has also been launched. And yeah, so that's it from my side. If you have any queries, I'll be happy to help you. Thank you. Okay. Yes, I'll share the source code. I would like to know something about YOLO in production. Yeah, I guess I already answered that question, Shovan. Um, yeah. So Yeah, I guess we have another 10 minutes. So if you want, I can, if you have any queries, I'll be happy to help. How do you convert YOLO weights? Yeah, so I'll share the source code. I mean, it's not much. Basically, you have to write a function which you can convert from YOLO weights to TF model. And even if you don't write it on your own, there are open source libraries available which are specifically meant for that. What is the advantage of YOLO v4 while compared to YOLO v3? Okay, frankly speaking, I'm not aware because I have not studied about YOLO v4. It is very recent, and I'm not even sure if it's available in Python. But I can tell you the difference between YOLO v3 and YOLO v2. So in YOLO v2, the Python wrapper of the YOLO v2 is called as Darkflow, and the title of the paper when YOLO v2 was released, the title of the paper was Smarter, Faster, and Stronger. So basically, it looked like a Complan ad, like which we hear in the TV. And the title of YOLO v3 is that smarter, not faster, but stronger. So YOLO v3 is more accurate, smarter as in more accurate, and it's not faster than YOLO v2, but it's also not slower. And yeah, so basically YOLO v3 is in production, and it's there is a lot of documentation. um, Sorry, yeah, thanks Amit. There is a lot of documentation available on the web for YOLO v3. And one more question is, I'm trying to use darknet and YOLO v4. Yep, Shovan. So yeah, that's what I'm saying. I mean, YOLO v4 is kind of recent. I guess it was launched in March or February, I'm not sure, this year. And I would suggest you to, if it's not that big a requirement, you go with YOLO v3, because YOLO v3 is tried and tested with so many people. As in, you would find tons of content on the web for YOLO v3. If you ever run into some problems, and if you ever face any errors, it can be solved very easily. But yeah, I mean, I honestly don't know about YOLO v4, so I don't think I can comment on it. But yeah, so and even we in our project Mavi, which I'm telling you, we are planning to use YOLO v3 and not YOLO v4. So yeah, yeah. I guess that answered it. Yeah, thank you. And anything else? If you, I'll be sharing the source code. It's not. It's fine. I mean, I can share it. I'll give you the GitHub link. You can clone it from there. And yep.
So if you have any more doubts, you can comment it on the chat. So I guess there aren't any. Oh, yeah, we have one.
Yeah, I'll do that. I mean, not in chat, but I'll ping Sukanya. You can ask from her.
Could you please provide source code or GitHub link in chat?
Yeah, I told that I'll provide it to you. You can share it with the others.
Yeah,
I mean, I haven't yet uploaded it on GitHub. I will have to make a new branch. Currently, it is just in same branch. I would remove a few things and add it and ping it to you.
so I don't think anyone has any
Yeah.
doubts anymore.
Yep.
So yeah, Thank you, Akhil, for the session. It was very informative and very nice to know that these new technologies have such high capacity of doing so many high level tasks. So yeah, I'll also be providing you a link to a feedback form DeepLearning.AI team, which will have a promo code with it, and you can use that code to purchase any of the DeepLearning.AI courses available on Coursera for a 50% off. So let me just provide you with the link. So yeah, here you go. Make sure you fill the feedback form in order to get the promo code. So, okay, I guess that's it for today's session. We've come to the end.
Yep. Thank you. Thank you, everyone. Bye.